Indicate which of the following statements are true and which are false. Justify your answers as best you can. Part A, for all x that's a positive integer, there exists a y that's a positive integer such that x equals y plus 1. This is false because if the statement were true, then the statement would be true for all positive integers x. Well, if we consider x equals 1, that's the smallest positive integer, there is no y that's a positive integer such that x equals y plus 1 because 0 is not a positive integer. You can't have y equals 0. So this is false specifically for x equals 1. And so if this is not true for all x, then the whole statement is not true. Part B, for all x that's an integer, there exists a y that's an integer such that x equals y plus 1. That's true because if you give me any integer x, I can find an integer y that's one value greater than the integer x. This is true. For example, if you pick x equals 5, then we just need to find an integer y such that x equals y plus 1, and we would pick y equals 4. And in general, for all x, we would pick y equals x minus 1. So we just decrease the value of x by 1, and that's the corresponding y that we can find to make the statement true. Part C says there exists a real number x such that for all real numbers y, x equals y plus 1. This is definitely false. There is no special number x that we can find such that x equals y plus 1 for all real numbers y. If you vary y over the real numbers, then x must also vary over the real numbers. So you can't find a specific fixed x that's a real number that satisfies this equation for all y. That's not possible. Part D says for all x that's a positive real number, there exists a y that's a positive real number such that x times y equals 1. This is true because if you pick any real number x, we can say y equals 1 over x. And since x was a positive real number, 1 over x is also a positive real number. And so this statement is true. If you give me an x value of, say, pi, then my corresponding y value would be 1 over pi to show that x times y equals 1. So each time you pick an x, the corresponding y is going to be the reciprocal of x. Part E says, for all x that's a real number, there exists a y that's a real number, such that x times y equals 1. This is also true for the same reason why D is true. If you pick any real number, then the corresponding y would be the reciprocal of x, so that x times y equals 1 is true. Part F says there exists a real number x, such that for all real numbers y, x plus y equals y. So to determine whether or not the statement is true, we have to find a special real number x that makes this statement true. Now there is a real number x that we can find, specifically 0, and we discover that for every real number y, x plus y equals y is true. Because 0 plus y is always going to be whatever y is. That's true for all real numbers. So this is true. Part G says, for all positive real numbers x, there exists a positive real number y such that y is less than x. This is true. If x is, for example, 2, then we could pick y equals 1. If x equals 0.5, then we could pick y equals 0.25. And in general, whatever we pick for x, the positive real number that we could find that's less than x, but still a positive real number, we would pick y equals 1/2 of x, or x divided by 2. So this statement is true. Part H says there exists a positive real number x such that for all positive real numbers y, x is less than or equal to y. That's false because if you notice, part H is the negation of part G. The quantifiers have swapped, and these two propositional statements are negations of each other. And so part G and part H are negations. Since part G is true, that must mean, therefore, part H is false. Now, why is part H false? We could say because for every value you pick for your positive real number x, there would be a corresponding positive real number y, specifically 1/2 of the value of x, that would make the propositional statement false. But for this specific x value, this has to be true for all y. So part H is false. Thanks, everyone, and I'll see you in the next video.